Today we begin learning about object-oriented programming. So we already know that all values are objects in Python, but we're going to start to understand what that really means. Object-oriented programming is a method for organizing modular programs, meaning that you define each piece without worrying about the other pieces, and then they all work together. So that means we're going to worry about abstraction barriers and bundling together information and its related behavior. Object-oriented programming is also a metaphor for computation using distributed state. What do I mean by distributed state? Well, we'll have a bunch of different objects, and each of those will have its own local state. So when we want to know what's going on in the program, we have to inspect each object in order to figure that out. Each object will also know how to manage its own local state based on method calls. So you call a method on an object, and that might change its state. The object knows how to update its state correctly. And those method calls are best thought of as messages being passed between objects. So that's the metaphor. We have a bunch of different things. Objects pass messages amongst each other, and each one is responsible for taking care of its own internal state. So what's going on with itself? Several objects may be instances of a common type, and different types may relate to each other. So we're going to see examples of all this stuff, but that's the basic idea that you want to understand when you think about object-oriented programming. And to support this metaphor, we're going to have specialized syntax and vocabulary in order to make this all make sense. So, we saw in last lecture that we might have different objects. Back then they were functions. Now there'll be objects that are John's account and Stephen's account. And let's say we have another object, John. I made it tall because, you know. And so what happens in this metaphor is that if John wants to withdraw money from his account to give it to Stephen, then there will be a message passed from John to the account. The account's business is to make sure that it knows how to withdraw money and update its balance correctly. So once John's done that, then it might send another message to Stephen's account saying, hey, deposit $10. And then Stephen's account's balance will be updated. Now the balance for each account is stored within the object, and John can ask for it using a message as necessary. And the idea is that all these different objects might have other messages coming in, and they might send messages to other objects as well. So John's account might occasionally say, after many withdrawals, John, it's probably time to apply for a loan. So that's the idea that we want to create when we write code in an object-oriented programming language, like Python. Fundamentally, objects are organized according to classes. A class serves as a template for all of its instances, and each object is an instance of some class. So we have built-in classes that we've seen along the way, but now we're going to start defining our own classes. So the idea is that all bank accounts will have a balance and an account holder. That's what makes a bank account a bank account. So the account class should make sure that every one of its instances has those attributes. What's its current balance, and who's the account holder. That'll happen when we create a new instance. And here's what the code is going to look like. We'll say, I'm creating an account, I'll pass in the account holder, Jim, and I'll bind the resulting object, which is an instance of the account class, to the name A. Then if I ask, well, who is the holder of A? The account holder is Jim. I set that when I called the account class to create the object, and now I can access it later as an attribute of that account. And what's the balance? Well, Jim so far doesn't have anything. So how's Jim going to have some money in his account? Well, we want all bank accounts to have withdraw and deposit behaviors, and all bank accounts should work the same way, which is why they're all instances of the same class. So if I deposit $15 into this bank account, which we've named A, that's Jim's account, now we'll get the balance back of 15. And if we withdraw $10, then the balance goes down to 5. What's the balance now? It's 5. So notice that some of these look like call expressions, and some just access a value that's part of the object. If I withdraw $10 again, I will have insufficient funds. So there's two different ways we could realize this. We could put deposit and withdraw methods as part of every single account, but that's not what we're going to do. Instead, we'll make sure that all accounts share the same withdraw and deposit methods. That way we can guarantee that they all behave in the same way, which is what we want.